I'm using a dataset with 100 data points, each described by 5 features. This forms the input for my MultiTaskLasso model. I've set the regularization strength, alpha, to 1.0. This controls how much I penalize large coefficients, promoting sparsity. I'm employing a MultiTaskLasso model. This is a type of regression model specifically designed to handle multiple target variables simultaneously, sharing learned information across them for improved efficiency and accuracy. It's a regression model, meaning we are predicting continuous values. I have multiple target variables that I'm predicting simultaneously with this model. This means that instead of having one thing to predict, I have several. The model learns to predict all of them using a single set of weights. Due to the L1 regularization, lasso, used by the MultiTaskLasso model, I expect many of the model's coefficients to be exactly 0. This is the hallmark of lasso regression. It's a way of doing feature selection and helps prevent overfitting. The core of the MultiTaskLasso model is that it uses one set of weights to predict all of my target variables. It doesn't create separate models for each target, instead, it cleverly shares information between them. Because I'm sharing weights across all targets, I anticipate a higher bias compared to if I trained individual lasso models for each target variable. The shared weights restrict the model's flexibility. I fit the MultiTaskLasso model to my dataset using the specified alpha value of 1.0. This means that the model parameters have been estimated based on my data and the chosen regularization strength. I'm evaluating a MultiTaskLasso model. This model is designed to handle regression problems with multiple target variables simultaneously. I'm working with a dataset containing 100 samples and 5 features. Each sample has measurements for 5 different characteristics, and we are predicting multiple outcome variables. My dataset's size, 100 samples and 5 features. This provides the data that the MultiTaskLasso model uses to learn the relationship between features and multiple target variables. The specific model I'm using is MultiTaskLasso with a regularization parameter, alpha, set to 1.0. This alpha controls how much I penalize the model for having complex coefficients, which helps prevent overfitting. This is a multi-target regression problem. I'm trying to predict multiple things at once instead of just one variable, which is the essence of MultiTaskLasso. I'll use metrics like mean squared error, MSE, to assess the model's accuracy. MSE measures the average squared difference between the predicted and actual values. I'm comparing the bias of my MultiTaskLasso model to a standard lasso model. Because MultiTaskLasso shares weights, it might be less flexible and therefore have higher bias. Because MultiTaskLasso uses L1 regularization, lasso's core component, I expect many model coefficients to be exactly 0. This sparsity is a key benefit of lasso. Yes, MultiTaskLasso uses a single set of weights for all target variables. That's what makes it a multitask learner, sharing knowledge across the prediction tasks. No, while MultiTaskLasso aims to minimize MSE, it does not guarantee the absolute lowest possible MSE. The constraint of using shared weights might prevent achieving the absolute minimum. I'm assessing a scikit-learn model called MultiTaskLasso. It's designed for regression problems with multiple outputs, meaning we're predicting several things at once using the same input data. This is different than creating a separate model for each output. We're deciding which statements accurately describe how MultiTaskLasso behaves when applied to the data with 100 samples and 5 features and the regularization parameter, alpha, set to 1.0. This focuses on understanding MultiTaskLasso's core properties. This statement explores whether sharing weights across all outputs, MultiTaskLasso, increases bias compared to creating separate lasso models for each output. I'll need to consider the trade-off between bias and variance. Higher bias means that our model is simpler and makes stronger assumptions about the data. Here, I'm examining if the model's characteristic of producing sparse coefficients, many weights will be 0, holds true. This sparsity is a direct consequence of using L1 regularization, which is a key part of Lasso and MultiTaskLasso. This statement checks if MultiTaskLasso's multitask nature, where a single set of weights is learned for all outputs, is a correct description of the model's behavior. The opposite would be learning different weights for each target variable. This tests if MultiTaskLasso guarantees to always find the absolute lowest mean squared error, MSE, across all outputs. MSE is a common measure of model performance, and we need to consider if the model's constraints prevent reaching the lowest possible MSE. I'm working with 100 data samples, each described by 5 features. This provides the input data for the model. Here, alpha is the regularization parameter that controls the strength of the L1 regularization. Setting it to 1.0 means a fairly strong penalty for having non-zero coefficients. This impacts sparsity and the bias variance trade-off. I'm assessing how well scikit-learn's MultiTaskLasso performs in a regression problem with multiple target variables. I'll examine its properties and how they affect model behavior. I have a dataset with 100 data points, each described by 5 features. These features will be used to predict multiple target variables simultaneously using MultiTaskLasso. I'm using scikit-learn's MultiTaskLasso, a regression model that handles multiple target variables efficiently. The alpha parameter, set to 1.0, controls the strength of regularization, how much it penalizes complex models. My goal is to predict more than one target variable at the same time. MultiTaskLasso excels at this, leveraging relationships between the multiple targets to potentially improve accuracy and efficiency compared to modeling them independently. I'm checking if MultiTaskLasso introduces more bias, simplification of the model to reduce error from the training data, than a standard lasso that fits each target independently. The shared weights in MultiTaskLasso can create bias. I'm evaluating if many of the model's coefficients, values that determine the impact of features, will be zero. Lasso regularization, a key part of MultiTaskLasso, encourages sparsity, leading to feature selection. I'm investigating whether MultiTaskLasso learns one set of weights for all targets, or separate weights for each. A defining feature of MultiTaskLasso is its use of a single set of weights across all targets. I want to know if MultiTaskLasso guarantees the absolute lowest mean squared error, MSE, a measure of prediction error, across all targets. It aims to minimize MSE, but there's no guarantee it achieves the absolute minimum compared to alternative methods. I've determined that statement A is true. MultiTaskLasso likely has higher bias than independent lasso models due to the constraints imposed by sharing weights across tasks. I've confirmed that statement B is true. MultiTaskLasso's L1 regularization will create many zero coefficients, leading to sparse solutions, a typical trait of lasso models. I've found that statement C is true. Because of its multitask nature, MultiTaskLasso uses a single set of weights to model all target variables. I've concluded that statement D is false. Although MultiTaskLasso aims to minimize MSE, it's not guaranteed to find the absolute lowest possible MSE, especially compared to fitting independent lasso models for each target. I'm assessing a MultiTaskLasso model, a type of regression model from scikit-learn that's especially useful when you have multiple things you want to predict at once. Think of it as a powerful tool for tackling multiple prediction problems simultaneously. Here's the core question. We're using a MultiTaskLasso model, a fancy regression tool from the scikit-learn library, to predict multiple outcomes simultaneously. We have data with 100 observations and 5 characteristics for each observation. I'm tuning model sensitivity to feature importance with alpha equals 1.0, and now I need to determine which statements about the model are accurate. Because MultiTaskLasso shares coefficients across multiple tasks, prediction targets, it might make simpler assumptions about the relationships between features and outcomes, resulting in higher bias compared to individual lasso models fitted independently. MultiTaskLasso uses L1 regularization, lasso, L1 meaning the model penalizes large coefficients. This encourages many coefficients to become zero, a process called sparsity, effectively selecting the most important features. That's the key advantage of MultiTaskLasso. It learns one set of weights, coefficients, which it applies to all the things it's trying to predict. This is what makes it efficient for multitask learning. While MultiTaskLasso aims to minimize the mean squared error, MSE, there's no guarantee it will achieve the absolute lowest possible MSE. The shared coefficients might prevent it from reaching optimal performance for each prediction target individually. It's a trade-off between overall performance across tasks and individual task performance. I'm working with a dataset containing 100 data points, each described by 5 features. I'm using a MultiTaskLasso model with regularization strength, alpha, set to 1.0. A higher alpha value means more regularization, resulting in stronger sparsity, more coefficients becoming 0. I'm using scikit-learn's MultiTaskLasso to build a model that predicts multiple things at once. Think of it like trying to predict both temperature and humidity based on the same weather data. I have 100 different samples, and each one is described using 5 different pieces of information, features. For example, if I'm predicting house prices, my features could be size, location, number of bedrooms, and so on. MultiTaskLasso is a specific type of regression model from the Sklearn library in Python. It's designed to handle multiple target variables simultaneously. This means I'm trying to predict more than one thing at the same time. Continuing the house price example, I could also try to predict property tax along with price. This is a parameter that controls the strength of L1 regularization. A higher ALPHA value makes the model simpler and less prone to overfitting. Think of it like adding a penalty to make the model less complex. This is the main question of my quiz. I need to evaluate several statements to figure out which are correct. I'm comparing MultiTaskLasso to the standard lasso regression, which only has one variable to predict. I need to determine if this MultiTaskLasso model will make more errors due to its assumptions. This statement is about the model's coefficients, the numbers that determine its predictions. MultiTaskLasso uses L1 regularization, which results in making some coefficients 0, thus simplifying the model and focusing on more impactful features. In this case, I will examine if MultiTaskLasso uses the same set of weights across all my multiple target variables. This statement is asking if the model is guaranteed to produce the most accurate predictions. I'll see if MultiTaskLasso can guarantee the best possible performance. I'm evaluating a MultiTaskLasso model. This model is designed to handle regression problems with multiple target variables simultaneously. It's like trying to predict several things at once using the same set of features. I have a dataset for training my model. It consists of 100 different observations, and each observation has 5 characteristics that I'll use to make my predictions. Think of it as having 100 people, and 5 details about each person. I'm using the MultiTaskLasso algorithm, specifically setting the regularization strength, alpha, to 1.0. This number controls how much I penalize the model's complexity. A higher alpha means more simplification. It's a crucial setting for preventing overfitting. I'm trying to predict multiple things at once. For example, I might predict both a person's height and weight based on the same set of features. MultiTaskLasso is perfect for this because it can find patterns in the features that relate to all of my target variables simultaneously. I'm asking, does using MultiTaskLasso result in more bias than if I trained separate lasso models for each target variable? Because MultiTaskLasso shares weights between the different prediction tasks, it might make simplified assumptions leading to higher bias. I'm checking if the MultiTaskLasso model produces a sparse solution. That means many of the coefficients, which represent the importance of each feature, will be exactly 0. This is inherent to Lasso due to its L1 regularization. I'm investigating whether MultiTaskLasso uses one set of weights for all target variables or separate sets. The defining characteristic of MultiTaskLasso is that it does use a single set of weights. I'm considering whether MultiTaskLasso guarantees the absolute lowest mean squared error, MSE. While it aims to minimize MSE, it's not guaranteed to find the very best solution because it's constrained to use the same weights across multiple prediction tasks. Yes, it is true. The shared weights and regularization in MultiTaskLasso can lead to higher bias than independent lasso models for each target. Yes, it is true. Because of the L1 regularization used in Lasso, and consequently in MultiTaskLasso, many coefficients will be zero, leading to a sparse solution. Yes, it's true. The core of MultiTaskLasso is its sharing of weights across all the target variables. No, it's false. While MultiTaskLasso aims to minimize MSE, the constraint of shared weights might prevent it from achieving the absolute lowest possible MSE across all target variables.